Experts tell us we create 2.5 quintillion bytes of data every day, and that 90% of the world's stored data was created in just the last few years. Where's all this data coming from? Well, the sources are pretty much anything you could imagine. Sensors, transaction records, pictures, videos, cell phones, just to name a few. The list could go on and on. Now, it's one thing to collect all this data. The real value, of course, is the valuable information that can be discerned from it. And that's exactly what we'll be talking about. The topic of our report today is advanced data intelligence and analytics. By viewing this program, IT and business professionals will have a better understanding of the technology, tools, and talent required to effectively manage and mine the volumes of data collected by global organizations every day. This program features expert Chad Jones, Chief Strategy Officer at Deep Information Sciences. Mr. Jones is a thought leader in many areas, including IoT, cloud, virtualization, and alternative energy technologies. There are several teaching points in this program. First, we'll define and explain advanced data intelligence and analytics and discuss the business insights that can be gained from mining enterprise data with cutting-edge tools and technologies. Then we'll talk about the challenges IT and business leaders will face when implementing these advanced data intelligence capabilities. We'll conclude with some helpful best practices, as well as hear additional thoughts and advice from our expert. Now, let's begin our report. In our first segment, we'll present a landscape overview of advanced data intelligence and analytics. We'll also discuss the business insights that can be gained from mining data with these new and innovative tools and technologies. The Data Warehousing Institute is an organization that viewers may be familiar with. The organization offers professionals a portfolio of business and technical education and research about all things data. In order to get a sense of how the market was thinking and acting in regard to the advanced intelligence and analytical tool and technologies, they conducted a survey of 325 IT managers, business users, and consultants at small, medium, and large companies. The interesting findings in summary are as follows. Approximately 30% of the 325 professionals surveyed are using advanced analytics tools on their big data sets. Business intelligence, data mining, predictive analytics, and statistical analytics type projects are benefiting from these advanced tools. 45% indicated big data analytics will allow for more accurate business insights. 38% of the respondents will use the tools to recognize sales and marketing opportunities faster and more efficiently. 60% anticipate that big data analytics will bolster their organization's social media marketing capabilities. The TDWI survey also revealed that the leading use case for big data analytics is advanced data visualization. In addition, there were some negative comments as well. The survey noted that over 45% of respondents pointed to the severe shortage of skilled professionals able to work with these advanced tools. In addition, high cost and the lack of business support were also said to be a significant potential roadblock. With those survey results in mind, let's introduce our expert and interview guest, Chad Jones, Chief Strategy Officer at Deep Information Sciences. Well, Chad, welcome to the program.
Thank you, Mike. I'm really happy to be here as well.
Now, Chad, our topic today is advanced data intelligence and analytics. What exactly does that mean to you? What comes to your mind first?
Well, we're inundated with a deluge of data from sources that we've been looking at for a long time in business, but a whole host of other sources, social information, devices that are out there today. And it provides us with a lot of opportunity to not only determine where we are today, which is typically business intelligence, but more to look at what we should do to take advantages of opportunities that we either see in front of us or maybe can get presented to us through analytics. Now, the old axiom is the only constant is change. Well, if the only constant is change and you can't see that coming, then if you don't adapt, then you're going to die. So really understanding and using the tools that are available today with some of these really cool things like predictive analytics to see where things can go and getting ahead of that curve allows us to adapt quicker. So to me, advanced analytics and that intelligence allows us to see almost the future and be able to react to it.
At a high level, exactly what types of business insights can one achieve with these technologies? Give an example.
Sure. Well, first one is cost cutting would be a really good example. Being able to analyze things like supply chains, logistics. Now, it's been around for a while, but it's ongoing, evolving science to see, well, how quickly can I get something where it needs to go? How quickly can I take parts from different resources and bring them together to manufacture something? And not only the time to market, but see how cost effectively I can bring those together. Being able to understand trends in how people react to things. Being able to see, okay, if a new product comes out, are people using it? How are they using it? How quickly are they adopting it? What are their usage patterns for that? And can that cross-reference something else in their lives that may be orthogonal to it, or maybe somewhat related, that gets us more intuitive about where we should take our products? Understanding things like in social networks, understanding sentiment is really an important thing these days. Before, we couldn't understand how someone felt about something without direct polling and questions and things like that. But what we can find now is analyzing the data can tell us, how someone felt on just how quickly they responded to something we put out. Something new that we put out in marketing, how quickly people responded to that, and gives us an idea if that is a great way to continue to invest dollars. There's some companies out there that are actually implementing predictive analytics on things like the Twitter feed, and we can understand ahead of time where things are going. Imagine if financial markets could understand the sentiment of investors based upon what they were tweeting about, or more relevantly, more to the point, we could understand chatter on terrorist networks and get ahead of where possible occurrences could happen because we were able to do this deeper level of analytics.
And Chad, what is driving all the interest in advanced intelligence and analytics today?
Right. Well, being able to understand markets is incredibly important. Seeing trends and micro trends in markets and being able to jump on those micro trends ahead of the competition is incredibly important. In the financial sector, the first company that brings a new financial tool to market captures 65% of the market, and everybody else fights for crumbs. So after that. So it's such a competitive market to be able to find whatever that micro trend is and create that new financial vehicle. It pays so much in dividends on getting ahead of the rest of the market. Same thing with personality trends and with user trends. Understanding how someone uses a product is as important as if they're using the product itself, because it can tell you what users are hoping to find in a product, and if it's intuitive and makes it easy for them to use, then they will go down that adoption path, and then learning how they adopt those products becomes really interesting as well.
And Chad, what types of organizations are currently benefiting from these advanced tools?
Right. Well, Mike, I'll tell you, it's interesting because the whole world can benefit from this in business, obviously. The question is how much money and access and personnel intelligence do you have to actually deal with the type of tools that you're looking at, because some of them are quite complex, right? So enterprises, obviously, financial enterprises, manufacturers, supply chain management, all of those companies are really using big data. Certainly the FedExes, UPSs, all of the logistical companies that are moving packages around, and time is obviously money. Amazon, huge, using these types of things. But small to medium business is using them as well. But what's great is SaaS-based applications are building in a lot of these analytical tools at a much higher level. You see Microsoft and Azure actually have a machine learning cloud, right? You're looking at, Google has some of this as well. And then you have Wolfram Alpha's cloud, right? And being able to take this high level of analytical capability, and a lot of times being able to have the machine tell you, what you should look at, because it's processing just oceans of data a human couldn't possibly look through that much data, is giving us tremendous insight. So small and medium business is starting to be able to access some of that because of the SaaS players out there. But then enterprises, certainly in financials, manufacturing, all of those things, are looking at this, but they have the money to go after them as well.
Tell us exactly where we are in terms of acceptance, implementation, and use. Are these technologies up and coming or more established than that?
Well, I think that we're in an interesting inflection point when it comes to data. Right? We keep talking about big data, right? Well, big data is just a bunch of bits that we have to be able to access that and get information from. That's really where our challenge lies now. So I think that we're at this, again, inflection point where we're going to have to make a technological jump to being able to use this wide variety of data that we have and be able to use it at a much deeper level and access much more of it. But the technology needs to have to go through a next evolution to be able to do that.
Chad, regarding your firm, Deep Information Sciences, tell us a bit about the products and services that are offered and what sets you apart from your competitors.
Right. So Deep Information Sciences looks at the world from a data perspective and says, look, everything from the 70s was great. All the algorithms and everything that were there were great for their time, but now it's the next turn of the crank. So what we were able to do is completely rethink the foundation of databases. And we have our own science that we've used, no longer B-trees or LSM. Our particular brand's called CASI. But now we're able to approach it very differently, and then we integrate machine learning with the engine that runs the database. But we run underneath MySQL, for example. So now MySQL plus us is something we call Deep SQL, and that allows the database to learn what's going into it and then to adjust on the fly to whatever those requesting workloads need. And it does it in an unsupervised learning way.
Next, we'll consider some of the challenges IT and business leaders will face when implementing advanced data intelligence and analytical capabilities. According to reports, experts, analysts, as well as IT and business leaders are all gung-ho when it comes to advanced data intelligence and analytics tools and technologies. They realize the advantages these tools will bring to global business that can be quite extraordinary. However, there is one big area of concern that might be a bit of a rain on the parade, so to speak. It doesn't involve any hardware or software issues at all. It simply comes down to a shortage of skilled personnel. You see, it's the data scientists who have the knowledge and ability to use these advanced tools to extract insights from the large volumes of data collected by organizations today. A report by McKinsey stated that by 2018, we will be short 190,000 data scientists here in the U.S. alone. As if that's not bad enough, McKinsey also tells us we will be lacking 1.5 million managers and analysts to support the data scientists as well. On the surface, this sounds pretty bleak, but there may be creative ways to deal with the situation. In fact, Paddy Padmanabhan, a business leader who has worked extensively in technology and analytics, offered insights about the IT skills deficit in a recent CIO online article. He optimistically reports that the emerging trends will likely address the talent shortage. Here are the 3 trends he identified that could help address the pending shortage of skilled IT personnel. The first trend is a familiar one: outsourcing. Padmanabhan states that offshore talent in the form of analysts and data scientists could step in to fill the talent gap. The second, automation. He states that more and more computing functions are being automated today. Automation will free up talent that would normally handle routine tasks such as data center management. These repurposed resources could also help fill the talent shortage. And finally, Padmanabhan's third trend is what he calls alternate education. By that, he is referring to finding substitutes for data scientists and analysts, such as PhDs in statistics and applied math. These individuals could be cultivated and trained and thus shore up the shortfall of skilled talent. Only time will tell how things will sort out. However, it will be an interesting journey, that's for certain. Now, let's continue our discussion on advanced data intelligence and analytics with our guest, Chad Jones. Chad, advanced data intelligence and analytics, break it down for us. What are its technical components?
Right. Well, the first thing is the database. We've got to store data somewhere, right? Now, what's interesting is that databases in and of themselves, you could have structured, semi-structured, or unstructured data. You can have relational databases and like SQL databases, things like that. And you have a newer kind of database that's NoSQL. Just throw all your data at it in any format, and then the application deals with it. Okay, but there are multiple sources that you have to consider and bring together. So the use case in which you want to approach your data will tell you a lot about which database you should use, right? And then you have, if you have something like Hadoop, then I've got to aggregate all of that data. So it may be the database and then an aggregator that I've actually got to go against. Again, it depends on the use case. But then I've got to be able to take and write queries against that sort of information. Right now, it doesn't have to be a traditional query, but still the number one interface that is written in right now for data is still SQL, structured query language, right? But then following that, you have tools like Excel that are still out there querying this information, which is pretty amazing, primarily in the financials. But then R is really widely used, and Python is widely used as well. So you have to write a lot of code to come and get this information, and then you've got to be able to report on it and visualize it. Right? So those types of tools are really important as well, to be able to say, look, let me spot trends after I put in my information and see where these things are going. Now, this is also where machine learning can come into play, because it can look at a lot of those different data sources, and based upon what you tell it to look at, it will learn over time what becomes more important and present to you what it thinks might be interesting, and you can compare that with what you were looking at.
Well, Chad, as you're aware, the massive amounts of data collected from sensors, devices, and from the IoT will drive some great opportunities for businesses. Now, acquiring the data is one thing, but using it effectively is another. We know that machine learning and analytics can help track, analyze, and interpret massive data sets. Please tell us about that.
Sure. So when you look at machine learning, right? It's a derivative of AI. Now, we're certainly not saying that the machines shall rise, but what machine learning is able to do is allow you to model a particular type of data set. And then based upon that, I can either in a supervised way teach the machine what to look for, and then set it off into an unsupervised learning mode, where based upon previous patterns, it will learn what is actually happening with the data, what is trending and what is important, and make its own correlations. There's numbers of protocols out there that allow you to do that, Bayesian, all of these sorts of things. And you can look that up, but the key is that over time, the machine will learn based upon the patterns of the data that are coming in from the different sources, what is a meaningful connection based upon very little learning that you give it, and then a lot of that learning it takes and does it in its own way to say, hey, I think this is important. And then you can determine whether that's important or not, and then kind of tweak its parameters a little bit here or there. As more and more data comes in, there's no way for a human, even today, to deal with just how many petabytes upon petabytes that come in, right? So you're going to have to rely on a machine, a well-taught machine and a learning machine, to be able to adapt to those situations and present more and more information to you and evolve the human's role into saying, I can look at this level of data and interpret it properly, and then make my own decisions on where I should take it.
So you've just said that 3 types of analytics are coming to the forefront: historical, predictive, and stream processing. I'd like to think that using a cross-section of all 3 is going to be key. Would you agree?
Sure. Well, Mike, it's a really interesting future, because in the past, we've only been able to look at the historical amount of data and say, okay, I see trends in the past, right? And I can say, well, you hear the commercials from the financial investment houses, and they say, well, past performance doesn't guarantee future results, right? Well, it tells us where we're going. We should learn from history. But now we have predictive algorithms out there, and they can take that historical information and not only see what actions actually, what the results were, but they can say, well, based upon certain things, I can model out and predict what would happen if I continued on this path, or if I tweak certain things, what if scenarios, those types of things. And based on other sorts of data that come in, those predictive algorithms can start to make leaps in logic of where things could go. And that's very interesting, because you can say, okay, especially in financial markets, sit down and say, well, I see where these different types of factors affected a certain company, and its stock price changed because of the changes in those factors, and it can become predictive on that. But what really becomes interesting is stream processing. So as an event occurs that we are watching either from a pure data perspective, looking at people entering information or how stocks are performing or something like that, but now we have the physical world with the Internet of Things that's telling us everything about, what's the temperature in a room outside, the humidity, how many times people have walked through a door. I mean, it literally goes on and on and on. That information coming in is sending events as they occur. Well, when those events come in, I've got to be able to calculate what's going on and understand that, and maybe I have a response from that. Maybe I let somebody know, hey, there's been a certain amount of events that have occurred in a certain area, we need to do something about it, or an automated chain occurs.
Now, Chad, I'll assume that organizations will need to develop a strategy to effectively deal with advanced data intelligence and analytics. Can you offer advice on creating strategy?
Sure. Well, the first thing, Mike, is that you have to think about the business use case first, because technology implemented for technology's sake that doesn't serve a higher first order purpose is doomed to mediocrity or failure. So you have to think about, what is the business case I want to satisfy first? What do I want to learn first? And then you backfill it with the technology. You then look at, okay, am I collecting all of the data points that I think could actually feed the answer for what I'm looking for? If the answer is yes, great. Are there other data sources that you could bring that would better triangulate for your answer? Right, so outside getting other sorts of data, things like there's temperature in certain spots, or FAA ground stops when rainy weather, and how often. All of those things can be made available to you. Can that dimension of data actually feed the other data that you have for your business? And then you need to consider at what's the nature of the answers. How fast do you need them? Do I need them in real time almost? Well, that means secondary systems and doing an ETL, that export, transfer, and load, is going to be difficult because the time factor, right? So can you have a system that is now known as HTAP, Hybrid Transactional Analytical Processing System, something that I can transact and be able to do analytics on the same data set without grinding it to a halt? So I have to consider that. Now, some data results may need that more real-time nature of things. Others may be more historical in nature, and I can wait for that ETL to occur. But you need to understand what the nature of that is, and then pick the appropriate technologies. And then, can you find the personnel that have the experience to go in and actually understand how to get you those answers, right? Again, data scientists are getting to be very, very hard to find, and they're expensive. Are there ways to look at outsource clouds to help you with that and deal with your data? Are there ways to get the right personnel to say, okay, do I have the right skills to deal with the right system as well to get those answers? So I would think about it: use case, technology, and then really make sure that you have the pieces aligned to get you the answer in the time you need them.
Now, you made reference to some challenges IT and businesses may face with these advanced capabilities. How can those challenges best be overcome?
Sure. Well, the database market is really in an interesting spot right now, as is analytics. Analytics with machine learning is just incredible how fast that's progressing. But the database world needs to now keep up, right? And that was the cycle of innovation that I talked about earlier. You see, databases are actually built on the 1970s technology. Most of them are, which are B trees, LSM trees, those types of things. Now, everything around those protocols, those algorithms that make the foundation of them, have changed over time and have wrung out more scalability and performance, but we're at the top of that, what those things can do. So it's really time to rethink that sort of thing. Plus, you have database architects or database administrators out there trying to run around and constantly tune databases to actually meet the needs of what the analytics platforms are looking for, and it's just never-ending cycle, right? So there's a new type of database space opening up now, and it's called the adaptive database, where these things are actually using machine learning as part of the engine to actually set up the data and present it as needed. It reorganizes itself on the fly based upon learning the requests of the different workloads from the database. That's pretty exciting, because that's taking the machine learning world of analytics that is using out to look at all of that data, but then also applying it to the engine itself so that it can answer those requests much faster. Now we're starting to talk about turns of the crank of innovation that can start to help us evolve to this next level.
We'll now conclude with some helpful best practices and added thoughts and advice from our expert. In today's report, we presented an overview of advanced data intelligence and analytics from a technical and business perspective. Then we discussed the business insights that can be gained from mining enterprise data with cutting-edge tools and technologies. We also considered the challenges IT and business leaders face when implementing these advanced capabilities. Next, we'll conclude with additional thoughts and advice from our expert. Chad, can you summarize some of your thoughts and advice today in the form of some best practices?
Right. Well, I think the first thing is to make sure that you understand the use case first. Understand the business need first. That is always the key. And across my career, I've seen that a lot of times people just want to jump into technology, and you got to focus on the use case first and backfill it and make sure the technology meets what you want the business to do. The next thing is keep an open mind, right? A lot of people are locked in and say, well, high performance, I really need to run to Oracle, right? Well, maybe you do, maybe you don't. Commoditized side is really, and open source has really come up through the roof now, and its performance and reliability and all of those things provides you a nice alternative. And then make sure you staff accordingly. You've got to have the right people with the right tools to be able to get the most out of that. You're going to have to look for them a bit, and you're going to have to pay for them, but it's worth it. It's worth 10 times what you're paying them once you're able to spot that first trend ahead of the market and capitalize upon that. And then from there, always adapt. Always adapt. Look at what's happening, go back, refine the process, and make sure that you are always trying to move ahead with personnel in there and keeping them educated, looking at systems and adding in new data sources so that these systems can actually present things to you through things like machine learning and these advanced analytics tools, so that you can continue to get ahead of the curve and create that, basically that innovation feedback loop, if you will. And that information keeps cycling. I get better, I learn more, I get better insights, my business capitalizes on those, more revenue, and then the cycle comes again and again.
Chad, could you please offer a final comment for our viewers?
Well, Mike, first of all, thank you very much for the opportunity to be here. Data is the key to unlocking the future. If we can look at what is happening under the surface, that gives us a key to how we should actually react and predict where we should go, both as businesses, perhaps as governments, and then see that loop occur for what our actions actually affect, and then learn from that, and then come back around and see if we can do things better. Being able to embrace that future on all levels is really the key to, I think, evolving who we are as a people.
Chad Jones of Deep Information Sciences, thank you for your time today.
Great. Thank you, Mike.
Well, that concludes our program, Advanced Data Intelligence and Analytics. I'm Michael Quinlan, and thanks for watching.